Hello everyone. In this session, I am going to review chapter number 4, elasticity. And this time, I am not showing you all those PowerPoint slides that I've already uploaded to your course website. What you have to do is to make sure that you read chapter number 4 and also go through all those PowerPoint slides because there are a number of examples that are given in those slides. So make sure you know how to calculate elasticity. And there are different types of elasticities which we are going to discuss in this session. So what I've done, I have just, summarize this chapter in 3 pages that I'm going to discuss in this session. So first, but make sure that you read chapter number 4 and also go through those PowerPoint slides as well. So let's start with elasticity. What is elasticity and how do we measure elasticity? So elasticity measures, just give me a second. This something is not working here. So let me fix, should not take more than a minute. Okay. Yeah. So first we define what do we mean by elasticity. So elasticity is a measure of how much the quantity demanded of a product changes as a result of a change in its price. So this is the definition of elasticity. That is how quantity demanded responds to a change in price level. This is elasticity, but this is also slope. And this is what I'm showing you on your screen. So what I've done, I have taken a simple example and I've taken a few points for, just give me a sec. Let me increase the font size. Yeah, 3. So see this. So I have taken this demand schedule or demand schedule. If you remember, we did this in chapter number 2. So this is demand schedule. That is, you have price level, sorry, on the in the first column and quantity demanded for this any product. Let's say is X is in the second column. You can see as price increases from $1 to $2 to $3 up to $11, quantity demanded decreases. This is what is law of demand, and we are assuming that all other things are held constant. That is the assumption of ceteris paribus. So this is the demand schedule. I can easily draw this schedule in in a two-dimensional diagram. That is what we call demand curve. One thing you must notice here, and that is important, that when we plot this demand schedule on a graph paper, we take prices on the vertical axis and quantity demand on the horizontal axis. Normally, we take independent variable, that is price, on the horizontal axis and quantity demanded on the vertical axis, but we have inversed it. We have reversed it. That is why this demand schedule, and when we plot this demand schedule into demand curve, so we are basically plotting inverse demand function. Let me write this, which is beyond the jurisdiction, but you have to understand this. So actually, quantity demand for X is a function of price of X. This is basically demand function. That is, price is independent. quantity demand depends on the price of the product. So if price changes, this will impact your quantity demanded, right? But we are taking price of X on the vertical axis. It should have been on the horizontal axis. It means that we are not plotting this function. We are plotting inverse of this function. That is, we write this function in this fashion, Px equal to, in terms of Q, right? In terms of QD. So we are basically drawing this demand function as inverse demand function. One thing. So you must remember that demand curve is the inverse demand function. It's inverse because we have taken price on the vertical axis and QDX on the horizontal axis. Why we are doing all this, why we are trying to learn this, I will tell you in a moment. Let me erase this. Now, if I ask you to calculate the slope of the demand function or this demand schedule. So slope is, I know, rise over run, but since I have drawn this demand curve as an inverse demand function, so I'm not going to take change in price divided by change in quantity. I will take the reverse. So if I want to calculate the slope of demand schedule, then I use this formula. Slope is change in quantity demand. This delta is change. So I'm not going to write change. I will always write delta. So change in QDX, quantity demand for X, divided by change in price of X. Okay, so this is the slope actually. That is, when price of X changes, how much quantity demanded for that product will change. And I know that they both move in the opposite direction. We know that law of demand shows that if price increases, quantity demand decreases. If price decreases, quantity demanded increases. So I know the relationship is negative. So I have calculated the slope using these 2 points. That is these 2 points. So see how I have calculated slope. So first I take here 20. This is first quantity demand. This is 20. And then I subtracted 18. So I subtracted 18. This is the change in quantity demanded. So actually, quantity demanded decreases from 20 to 18. Okay. And then I take the price. And this is the the trick. The trick is always take price that correspond to this 20 at the first place. So with 20, this is the price 1. So always write 1 here. So 1 and 20 must be on the same place in the numerator and in the denominator. And then 18 price corresponding to 18 is $2. Then just below 18 write 2. So I know I'm writing here. So 20 minus 18 equal to what? 2 divided by 1 minus 2 is actually minus 1. 1 minus 2 is minus 1. You can use your calculator. 2 over minus 1 is actually minus 2. You will always get this negative number, always, for only price elasticity of demand. So, but I'm not calculating price elasticity of demand. I'm just calculating slope, and slope will always be negative. Always. Why? Because I can see this is a negatively sloped line. That is, these two variables are inversely related. So one thing I know that the slope of this demand schedule is minus 2. If you ask me what is the slope of this demand curve, which is rise over run, that is change in price of X divided by change in price of quantity demanded, I just reverse it. I don't need to do anything. So I know the slope is minus 2. So slope of the demand curve is minus 1 over 2, reciprocal of 2. So if the slope is minus 3, then the slope of the demand curve would be 1 over minus 1 over 3. So whatever number you have, you just take a reciprocal. Okay. Now, once you know, then we will discuss what is the meaning of this slope. Because if you don't know the meaning of slope, you will not be, it would be very difficult for you to understand the concept of elasticity. So now I have calculated slope as -2. Notice in this data, the table that I provided, it doesn't matter whatever point you take, any 2 points take on this demand schedule, you will always point slope equal to -2. So for example, if you take, let's say, if you take this 16 and this 3 and take this 2 and then 10, you will still get the same answer, that is -2. How? Like this. So 16 minus 2 divided by 16, then price is 3, and for 2 price is 10. So 16 minus 2 is 14, 3 minus 10 is -7, 7 2 is 14, so you get -2. So it doesn't matter which 2 points you consider, the slope is constant. And I've given you this example so that slope is constant. And that is the reason. If slope is constant, and when you draw this information on the graph, you will always get a straight line. So remember that the slope of a straight line is always constant. Not necessarily -2. It could be -3. It could be -1. It could be -0.5. Any number with a negative sign. Now we try to explain what do we mean by this -2. Minus simply shows that these two variables are inversely related. So if one increases, the other one must decrease. This is the meaning of negative sign. What is the absolute value of this slope? Absolute means just ignore negative sign. So absolute value is 2. What is 2 in the slope? 2 is defined here. That is, if price of X increases by $1, quantity demanded for the same product X decreases by $2. This 2 is actually the slope, and where negative sign is depicted here. If price increases, then Q decreases. So they are moving in opposite direction. Are you getting my point? So for example, if slope is -4, it means that if price of X increases by $1, quantity demanded decreases by 4 units. So this is the meaning of slope. But we are not interested in slope. We are interested in elasticity, because sometimes absolute value, that is this 2 units, does not give you an actual how do I say? Let me give you an example so that you understand, right? So for example, if I'm saying that if price increases by $1, it doesn't mean anything. Why? Because suppose if price increases from 100 to $101, this is an increase of $1. And if price increases from $1 to $2, this is also $1 increase. But notice these two are totally different. Here, the increase in price is only 1%. That is from 100 to 101, nothing. And here, $1 then to $2 is 100% increase in price. So dollar amount will not give you the true picture, okay, that you can analyze. So what we are going to do, instead of calculating slope, we calculate elasticity. What is elasticity? We want to see if we increase price by not $1, by 1%, what is the decrease in quantity demanded in percentages? So you are basically getting rid of, okay, if I said it's not accurate, that is not true basically, but it avoids any units. Are you getting my point? So if you are it's basically in percentages, so it's unit free. So it doesn't matter X is in kilos or pounds or in liters or in weight, whatever. When you convert these numbers into percentages, it is much easier to compare as well. So for example, if I say if price of X increases by $1, the quantity demanded for milk will increase by 3 liters and quantity demanded for meat will increase by 2 pounds. It's difficult to compare. But if we convert everything into percentages, it is much easier. So I can easily compare which product has more elasticity, that is quantity demanded, responded to the changes in the price, whether this response is high or low. I'll discuss in detail as well. So how we are going to calculate then elasticity of demand? So like slope, we calculate elasticity of demand, which is very similar. If you look at this and compare these two formula, let me mark here. If you compare these two formula, this slope with this elasticity, see, I have taken change in quantity demand for X. Here I'm taking percentage change in quantity demanded for X. Here I take change in price. Here I'm taking percentage change in price. So it's very similar. It's not slope. It's very similar to slope. Only difference is I'm taking percentage changes instead of absolute changes. So now this number I know is also a negative number, always. This number will always be a negative number. So you always have price elasticity of demand, that is a negative number. Now let's take any number, which is not written here. I just wrote negative number. Let me take an example. Suppose if you calculate, and I'll show you how to calculate it. If you have this elasticity of demand, and we use this symbol, the Greek letter epsilon, right? Epsilon, E-P-S-I-L-O-N. So suppose the elasticity of demand is, let's say, minus 2.3. Remember, although I haven't written a percentage sign here, the percentage sign is hidden. Let me interpret this coefficient and you'll understand. By minus 2.3, we never write minus 2.3%. We always write minus 2.3 or without percentage sign. Minus 2.3 minus, just ignore this minus because this shows a negative relationship between price and quantity demanded. What is 2.3? 2.3 is if price of X increases by one, not dollar, 1%. Then quantity demand for X, I know will decrease, but by how much? By 2.3%. So this 2.3 is this coefficient. Okay. Now we have certain 2.3 is this coefficient. Okay. Now we have certain terms that we use. So let me erase this. Since it is already been recorded, so even if I erase, you can always go back and see what I've written here. So now there are certain terms that you should know. First, so these are the three terms. Oh, sorry, hold on. These are the three terms. Number one, notice that the two vertical bar before and after the symbol epsilon shows absolute value or modulus. So this is the absolute value. So I'm not considering negative sign here. In price elasticity with demand, you will always calculate a negative number, but we don't consider negative sign when we further analyze that coefficient. So we are just ignoring that negative sign. That's why I wrote epsilon in this fashion. That is absolute value of epsilon. If the absolute value is greater than 1, doesn't matter how much, 1.5, 1.2, 5, 6.9, whatever, but greater than 1, we call it elastic demand. So if the elasticity of demand is greater than 1, we call it elastic. If the elasticity of demand, that is absolute value, is equal to 1, exactly equal to 1, 1.0, this is called unit elastic. And if the absolute value of the elasticity is less than 1, this is what we call inelastic demand. Okay. So these are, you must remember these: elastic, unit elastic, and inelastic. Now, before going to give you the formula how to calculate elasticity of demand, let's discuss determinants of price elasticity of demand. So instead of writing whole term, I just wrote PED, price elasticity of demand. What we are going to basically discuss in under this heading, you know that price elasticity of demand is the responsiveness of changes in quantity demanded due to changes in price level. So if price changes by 1% and your quantity demanded changes more than 1%, that is elastic. If price changes by 1% and quantity demanded changes by less than 1%, that is inelastic. If price changes by 1%, quantity demanded also changes by the same 1%, that is called unit elastic. So what are the determinants of elasticity of demand or price elasticity of demand? What I'm trying to discuss, that what are the factors that make that product more elastic or inelastic? What are those factors? How do I know that a specific product has a high elasticity or lower elasticity? That is, whether the demand is elastic or inelastic. How do we know? These are the five factors. Number one, availability of substitutes. So if there are more substitutes available, the product has an elastic demand always. Why? It's pretty logical. For example, if I take the example of, let's say, margarine and butter, and if I know that these two are substitutes, and suppose if there are other substitutes available for butter, what would happen? If price of butter increases, then quantity demanded for butter will decrease sharply. So if price increases by 1% or 2%, quantity demand decreases by 4 or 5 or 6%. Why? Because there are other substitutes available. So you can easily go and buy that substitute. So if there are more substitutes available, the product has elastic demand. The elasticity of demand is elastic. Second, necessities versus luxuries. Elasticity of demand for necessities is always very low. That is inelastic. So if for example, life-saving drugs, so these are necessities for those who actually depend on those medications. If price increases, they're not going to reduce their demand. Maybe they might reduce, but a little bit. And therefore, of course, with the permission of the doctor, and therefore the demand is pretty inelastic for necessities. For luxuries, the elasticity is very high. That is, when price increases for luxury products, you demand, or the quantity demanded, will decrease a lot. Why? Because that product is not a necessity. Reverse is also true. That is, when price goes down slightly, people would buy more. So they are more responsive to those products. Definition of the market. Actually, all these factors are interrelated, right? By definition of the market, I mean whether you are considering a product in a broad perspective or in a narrow perspective, right? So, for example, if you're considering a product that is, let's take this, food. Now, food is basically a very broad category. There's so many things that are included in food. Basically, we can't survive without food. So the demand is inelastic. So if you are taking in a broad perspective, the product is inelastic because you can't survive without food. So if price of food increases, your demand will not decrease a lot because you have to depend, you have to survive. And if you consider this product bread, this is narrowly defined. So this is one specific type of product, bread. And therefore, there are other substitutes available for bread. So you can buy other substitutes for bread. Even within bread category, there are so many other substitutes. Whole wheat bread, white bread, this bread, that bread, with cheese, whatever. So the elasticity of demand for bread will be high, and therefore it's elastic. Why? Because you have more substitutes. So if you consider narrowly defined product, that is higher elasticity. If you define broadly, uh, if you define in a broad perspective, then the product would be inelastic. Percentage of household income is spent, that is also very important, and that has to do with, again, luxuries products. So see, if suppose if you are if I take one product, let's say salt is a product. If I want to know what should be the elasticity of demand for salt, then I know that it costs you only $1 or $2 at the max, and you will get the whole box that will last for 6 months or four months. So you are spending a small percentage of your income on salt, and therefore your demand for that product, that is quantity demand for that product, will be very highly inelastic. Highly inelastic means that if the price of salt increases from $1.5 to $1.7, you are not going to stop using salt because this is more expensive. So you are not, changes in price is not, you are not responsive basically to those to the changes in the price level. Why? Because just $1 or $2, it's a very very small percentage of your income. Yes, if it has a major expenditure in your income, then you will probably think so. It's not, for example, if you go to Home Depot to buy a refrigerator, you know, you have to consider. So you will be very responsive to the changes in the prices, but not for salt. And fifth one is time period. So products are inelastic in the short run and elastic in the long run. For example, today, if I have to go to Calgary from Red Deer and I go to the gas station, this is a short run, I have to go there. So even if the price of oil or gas is 1.3, I have no option but to fill my tank. And therefore, my quantity demand for that product is pretty inelastic. It's not responsive to the price. But if, for example, if I have to go to Calgary after 1 month, then I'm more responsive to the changes in the price level. So I will just search online and on gas station when the price is low, and then I will uh, buy or fill my tank. So see, in the long run, you have enough time to adjust yourself, and therefore your demand is elastic. In the short run, it's inelastic because you can't do anything. So these are the five determinants of price elasticity of demand. Now let's see how we actually calculate elasticity of demand. Although I have given you this formula, percentage change in quantity demanded divided by percentage change in price for the product X. How are we going to calculate percentage change in quantity demanded and percentage change in price of X? So this is the formula that you are going to use. Change in quantity demanded divided by average quantity demand times 100 divided by change in price of X divided by average price times 100. Now, let me first tell you how to calculate percentage change. Okay, percentage change, how we calculate this. Let's take this example. Okay, so I'm just taking a random number and then I'll discuss the example that I've given here. So suppose let's take a two value of Q1, quantity demand. So I'm not writing QD, Q1. Let's say this is 100 and Q2 equal to, let's say, 150. I want to find out what is the percentage increase in quantity demanded. I know 50 units is increased. Okay, so the output increases by 50 units. This is, I know, in units. But in percentages, how do we calculate? So the rule is first always calculate the change, the absolute change. So absolute change is 100 minus 150, or 150 minus 100 doesn't mean, just ignore the sign for the time being. This is basically 50. So I know change in quantity is 50. Okay. And then you have to divide this change by any one of these two, either Q1 or Q2. So suppose if it is increasing, right? So suppose if output increases from 100 to 150, so 50 is the change. So okay, let me erase this and write the complete thing. So this is how I write. So right now I'm considering that we are moving from Q1 to Q2. Okay, Q1 to Q2. Let's calculate. So 150 minus 100 divided by, always write 100. Why 100? Because we are starting from 100. So initial value is in the denominator and the numerator is the difference between these two. Of course, this is the new one price and this is the old. So 150 minus 100 divided by 100. So this is 50 divided by 100. And then 50 divided by 100 is what? 2. So 1 over 2. And 1 over 2 times 100. This 100. This was 100. This 100. So divide by 100. So this is 50%. So 50% increase in quantity demanded. If you move from Q1 to Q2. Now there's a problem. The problem is, for example, I'm not going to erase this. If I ask you in units, right, not in percentages. If I ask you, when I move from Q1 to Q2, there's an increase in 50 units, right? And if I tell you, if you move from Q2 to Q1, exactly opposite, that is output is decreasing, you know that if you move from 150 to 100, again, $50 loss. So in one case, it's a 50 units, not dollar, 50 units gain. And if you go on the other side, it says $50 decrease in this product. Simple. But in percentages, it's not going to happen. Or it's not going to be the same. For example, I just showed you, if you move from Q1 to Q2, so 150 minus 100 divided by 100 will give you 50%. Now suppose if we move from 150 to 100, like this. So we move 100 minus 150. So this is the initial now. Always we write initial at the end, right? After this minus sign. So 150. So basically output is decreasing from 150 to 100. So 100 minus 150 divided by 150, because this is the initial value. You are here and then you move to Q1. So can you calculate 50 divided by 150? So this is 1 over 3 times 100. So 1 over 3 times 100 is 33.33%, if I'm not wrong. Now see, you have a different answer. If you move from Q1 to Q2, there's an increase in 50% of output, 50% increase in the level of production. If you move from Q2 to Q1, then there's a decrease in 33% in the output. Why? Because in percentages, it matters from which is your initial point and which is your final destination. For example, let me give you one simple example. If price increases from $1 to $2, that is 100% increase. How I calculated 100%? From 1 to 2. So second number first minus 1 divided by 1 times 100. That is 100%. If you calculate 2 minus 1 is 1 over 1 is 1 times 100, 100%. But when price decreases from $2 to $1, this is only 50%. You can calculate like this. So initial value is now this. So 1 minus 2 divided by 2 times 100. So this is minus 50%. So increase is 100%, but decrease means negative, is only 50%. That is the problem. That is what I have given you here. So I'm just deleting this information. This is just an example. Sorry. Just give me a sec. So this is the example I've given you, that if QDX, if you have two numbers, hold on. If you two numbers, instead of 100 and 150, 55 and 60. Okay. So change in quantity demand is always 5. It doesn't matter whether you are moving from 55 to 60 or from 60 to 55. So if you divide this number by 55, you get 9% answer. If you divide by 60, you get 8%, different answers. So in order to tackle this problem, what we do, we don't take 55 or 60, we just take the average of these two numbers. It's much easier. So instead of taking 55 or 60, we just take 55 plus 60 divided by 2, average. So that would be 57.5. So that is why I wrote average Q. Okay. So we are not dividing by any one specific quantity. We are just taking the average. Similarly, change in price of X divided by average of the two prices times 100. So not always, if you are given two quantities and two prices, you can easily first calculate the change and then divide by the average of those two numbers. And you will get the elasticity of demand. Okay, so now let me just go back and show you one thing. So I have to go. Just give me a second. Let me go here. So that you know what I'm doing here. So now I have uploaded PowerPoint slides for chapter number 4, elasticity, and I've discussed everything that is written here. So these are some of the examples. So fresh tomatoes, elasticity is 4.6, highly elastic, because you may find other substitutes like yogurt. Movies, elastic. Lamb, elastic. Restaurant, elastic. China and tableware, elastic. Automobiles, elastic. Elastic means greater than 1. I know that all these numbers are in negative with a negative sign, but we just ignore negative. Look at the inelastic demand. Household electricity. There's no other substitute. X, sorry. Car repairs in inelastic demand. Food. See, not bread or any specific product, but food. The general broad perspective, right? Household appliances, necessities maybe. Tobacco is an addiction, and that is why the price elasticity of demand is less than 1. That is inelastic demand. So this is what I have already shown you this formula. Change in Q divided by average Q, change in P divided by average P, average price times 100 times 100, right? Now, this is the slide. I'm not going to go through. You have to go through this. This is an example how to calculate elasticity of demand. So if you notice here, this is 100 divided by 1050. There's no 1050 here in the data. Why 1050 is the average of quantities, quantity demanded. So this is 1000 and 1100. So the average is 1050. That is why we have taken 1050 here. Okay. And you can see these are the prices, 650 and 550. So this is 1200. If you add and divide by 2, 600. So this is the average, 600. So we are taking price, average of price and quantity demanded. And notice that if 1 in the numerator, if Q is positive, positive means that we have subtracted 1000 from 1100. So first we take 1100 and then 1000. So you do the same here as well. First take 550 and then 650. So 550 minus 1100 and then 1000. So you do the same here as well. First take 550 and then 650. So 550 minus 650 would be a negative number. So that is why you have a negative number here. So one number must always be a negative number. Okay. So these are the example, and they have calculated minus 0.57. Inelastic demand, because less than 1. The absolute value is less than 1. And what is the meaning of 0.57? If price of this product increases by $1, then the quantity demanded will decrease by 0.57%. Okay. Now let me go back to the my notes. Okay. So So this is page number 2. Now what I'm going to do, I'll further elaborate this formula, right, and make it more easier to calculate. So I just rearrange, and this is in your textbook as well. I just rearrange this formula into in the following form, and you can see what is the following form. So what I have done, see this. Hold on a second. Let me. Okay, hold on. So see what I am doing. This change in Q and this change in P. Okay, I wrote here this change in Q and this change in P. And P is in the denominator and in the denominator. So if I take in the numerator, it can go here. And this Q is already here. So I just changed the, but instead of this divide sign, now you have this multiplication. Okay. And then I rearrange. So I take this change in P here and Q here. Just switch their places. So I get change in Q divided by change in P times P over Q. Remember, this P is average P. This Q is average Q. Not only one P, the average of the two prices. And similarly, average of two quantities. Now, I know when I started this session, I told you how to calculate slope. And slope is this, change in Q. Hold on. Let me first erase this. Hold on a second. So this is what? This is the slope, not of the demand curve, but of the demand function. If the slope of the demand curve, you want to use slope of the demand curve, then you have to take the reciprocal. So you write formula like this, epsilon equal to 1 over slope times P over Q. And P is average. And Q is also average. So this 1 over slope, this slope is the slope of the demand curve, not demand function. Are you getting my point? I've given you. So suppose if it is, let's say this change in Q or change in P is -2. Okay. You have to write here -2. But suppose if the slope of the demand curve is given as 1 over 2 minus reciprocal 1 over 2, how you write there? So you write like this, 1 over 2 minus. And of course, 1 over 2 is nothing but -2. Same thing, okay? But remember, this change in Q over change in P is not the slope of the demand curve. That's why I just wrote slope. I did not write slope of the demand curve. This is the slope of the demand function. And I did not intentionally write demand function because I did not discuss demand function in detail. And that is not included basically in this course. I'm not going to discuss the function in detail, but you remember change in Q or change in P is the slope, and slope of the demand curve is opposite, absolute, the opposite, the reciprocal. Change in P over change in Q. Not change in Q or change in P, but change in P over change in Q. Now, so this is all as far as the price elasticity of demand is concerned. Now I'm going to discuss the second topic, and that would be the last topic for this session. So this is part 1 of chapter number 4, and then I will upload part 2 of the same chapter. Okay, so we'll discuss only this this last topic here, elasticity and total revenue. What is the relationship between elasticity and total revenues? So remember that total revenue is simply price times quantity. So this is the meaning of total revenue. Now I will discuss, and I've already written down, so this is recorded, so you must know all these relationships. I'm sorry, these are too many relationships. Now see, first I consider elasticity greater than 1. Although I did not put an absolute sign, but I mean it's a positive value, right? So we are just ignoring negative sign. So if elasticity of demand, the absolute value of the elasticity of demand is greater than 1, that is elastic, what would happen if price increases and price decreases to total revenue, not to quantity demanded? I know quantity demanded will increase more than the increase in prices, I know, but we want to see how total revenue changes if price increases or decreases. So see this, if price of X increases, I wrote total revenue will decrease. How do we know? How do I know? I will use this equation and easily show you, of course, theoretically, right? So see what is happening. I know, remember that demand is elastic. That is greater than 1, okay? So see this. Suppose if price, it's not working. Hold on. Let me erase this. I'm sorry. Let me do this again. Yeah. So see, total revenue is price times quantity. This is total revenue. Suppose if price increases by 5%, then your total revenue will also increase by 5% if there's no change in quantity, right? But since demand is elastic, the quantity demanded for the same product will decrease more than 5% increase in price. That is the meaning of elastic demand. So quantity demanded will decrease by, let's say, 10%. By 10%. What would happen? Yes, price is increasing, but quantity is decreasing more than 5%. So what is the net impact? The net impact is that total revenue will decrease actually. Although price is increasing, but only by 5%, but people are not demanding. The quantity demanded decreases by more than 5%. So your total revenue will decrease. This is what I've shown here, that if elasticity of demand is greater than 1, if sellers try to charge higher prices, their total revenue will decrease actually. Okay. Now, if price increases by 5% and quantity demanded decreases by 10%, it means that elasticity of demand is -2. How do I know? See this. What is the meaning of -2? -2 means if price of X increases by 1%, quantity demand for the same product X decreases by 2%. So for each 1%, you have 2%. So if the price increases by 5%, then 5 to the 10%. So 5%, then 10%, twice. That is why I wrote -2. Okay. And then I don't have to explain all this stuff again. If price decreases, total revenue will increase. So there's one conclusion. Let me show. So if you are selling a product and your product has elastic demand, that is, people are more responsive to the changes in the price of your product, then if you want to make more money, always reduce price. So you'll always find sales on those products that have elastic demand. There's no point putting products on sale with an inelastic demand. So normally you don't see sales on cosmetics or those products that have very low elasticity. For example, tobacco. So you notice here that in both cases, in this case and in this case, the two variables, price and total revenue, are moving in opposite direction. If price of X increases, total revenue decreases. If price of X decreases, total revenue increases. So this is the relationship is inverse or negative relationship between price and total revenue if elasticity of demand is elastic, that is greater than 1. What if it is less than 1? The relationship is direct. So if you are selling a product that has inelastic demand, Inelastic demand means if you change the price, quantity demand will not change a lot. What are you going to do? You will charge higher prices because you know consumer will buy anyways. So in that case, increasing price is always beneficial. See, if you try to charge higher prices for the product that has inelastic demand, your total revenue will increase actually. But if you put your product on sale with an inelastic demand, you are going to lose money because people are not going to buy more because demand is inelastic. It's not responsive to changes in the price level. And therefore, I'm just labeling this, circling this, and this. These are too important. So whenever demand is elastic, this is the best policy to lower prices. If demand is inelastic, charge higher prices. And you can see in this inelastic demand, they both are moving in the same direction, and therefore we call it the relationship is direct. If the elasticity of demand is unit elastic, exactly equal to -1, but we ignore minus sign, what would happen? Nothing will happen. If you increase the price of your product or decrease the price of your product, your total revenue will not change. How do I know? This is basically, so total revenue is price times quantity. If you increase price, let's say by 5%, then quantity demanded will decrease by 5%. Same. That is the meaning of unit elasticity equal to 1. Then quantity demanded will decrease by 5%. Same. That is the meaning of unit elasticity equal to 1. So every 1% increase in price, quantity demanded will decrease by 1 percentage point. So 5% increase, 5% decrease, and they'll cancel out. Total revenue will not change. So if the demand is unit elastic, there is no change in total revenue. So this is the relationship between elasticity and total revenue. Now I've drawn, you don't have to draw diagrams in your midterm and final exams because online is difficult. But in your assignment, I don't remember, but if you have questions where you're required to draw diagrams, you can draw diagrams by hand, take a picture, and then attach as a picture in a picture mode to your Word document, right? But handwritten assignments will not be accepted. So you have to type in a Microsoft Word, and then you can paste your diagrams if you are asked to draw diagrams. Okay, so these are different types of diagrams. First diagram that I'm going to consider is this. Let me first erase this. So this is the first diagram. Remember that I told you that if you have a demand curve that is a straight line, the slope of this demand curve is constant. I showed you earlier at the very first page, in the very, at the outset when I start this session, that the slope was -2, if you remember, and which was constant. But elasticity is not constant. Remember, slope is constant. That every time when you increase price by $1, quantity demanded decreases by 2 units. That's fine. That is constant. But elasticity of demand, that is every time when you decrease price by 1 percentage point, quantity demanded increases by not all the time 2%. No, it is different. I can show you here. Why this is so? Because see this table, demand schedule. Quantity demanded decreases from 20 to 18. So this is basically $2 decrease out of 20. Okay, you calculate the percentage, and then $2 out of 18, you have a different number. So in percentages, they are different. If you increase price $1 to $2, it's 100% increase. But if you increase price from 2 to 3, it is only 50% increase, not 100%. In percentages, there are different numbers, right? So you have different elasticities. Now notice one thing, that if the let me go here and see this, what is happening. At a very high price level, for example, if price increases from if price increases from 10 to 11, what is in percentages? I know $1 increase in price, but what is in percentages? That is 1 over 100. That is 10%. So only 10% increase, right? Only 10% increase in price. Now see here. Okay, give me. Is 100% increase. So as price increases, the percentage change in the price decreases. So if you increase from $1 to $2, it's 100% increase. But if you increase from $10 to $11, it's just 10%. So the higher the number, the smaller the percentages. The reverse is also true. Look at this. If you increase from 0 to 2, it's a 200% increase. But if you increase from 2 to 4, it's only 100% increase. So if the number are smaller, percentage changes are bigger. Okay. Once you know this, let me show you here. So this is the diagram. And in this diagram, what I'm going to show you first you should know the formula. So I'm writing formula and I'll explain one thing and then everything will be easy. So I'm writing here percentage change in QDX divided by percentage change in PX. This is the formula. Okay. Now, if you are in this range, prices are higher and quantities are lower. And I told you when quantities are lower in percentages, that's the big number. So this number is bigger. And oh no, price is bigger. So this number is no, hold on. Let me erase this. I don't know what I said. I even don't remember. Okay, let me again. So percentage change in QDX divided by percentage change in PX. Okay. Now let's suppose you are at this point. At this point, notice price is very high. And I told you if price is very high, percentage change in price is very low. So this number is very low number, a small number. And at this point, if you notice, quantity is at the initial stages. So percentage change will be very high. So this number will be very high. What happens if numerator is higher and denominator is lower? It means that this whole number is greater than 1. Higher number. Okay? Definitely higher number. If the numerator is greater than denominator, like this, 3 divided by 2 must be greater than 1 number, right? This is 1.5. But if opposite is the case, 2 divided by 3, then it's less than 1. That is how much? So 0.66. Okay. So in this range of the demand curve, elasticity of demand is elastic. In the middle of the demand curve, we have unit elasticity. And below this middle point to the end, elasticity of demand is less than 1. This is the rule for a single straight line demand curve. You have different elasticities on the curve. That is one point. Second, if you are not talking about elasticity on each point, then I have drawn. Okay, let's discuss this first. So see here, I have shown you the relationship here. Sorry. I've shown you all these relationship here. That is elasticity and total revenue. So I drive total revenue curve here. This is total revenue curve. This is total revenue curve. See what is happening. Notice I've taken quantity demand on the horizontal axis, total revenue on the vertical axis. See, in this range, demand is elastic. That is this, elastic. And if I decrease prices, what happens? Total revenue will increase. That is why I'm increasing total revenue. At E equal to 1, that is this case, elasticity will not change. So it is the maximum point. Then in this region, when elasticity is less than 1 inelastic, that is this region, if you decrease price, because we're moving in this direction, if you decrease price, total revenue will decrease. The total revenue start decreasing. So this is a total revenue shape curve. It's a inverted U shape. Now I've drawn 5 other diagrams. Let me quickly explain these diagrams and then I'll stop here. This is the elastic demand. How do I know it's elastic? Because you can see it's more flatter. Flatter means if you change the price a little bit, only this much. Look at the quantity demanded, a lot. So if there's a decrease in price a little bit, that is 5%, quantity demanded increases by more than 5%. So the whole curve is elastic. I know on each point you have different elasticity, but the whole curve is elastic. If a curve is more steeper, like this, the elasticity of demand is inelastic. That is, see this, if I change price from here to here, this much, very high, but quantity demand is increasing only this much. So quantity demanded is not responsive to changes in prices. That is the definition of inelastic demand. This another demand curve, that is this. See, whatever be the price, quantity demand is the same. So elasticity of demand is 0. These are basically life-saving injections. Whatever the price, doesn't matter, you have to buy it. So elasticity is 0. 0 means your demand is not responsive to prices, changes in prices. This horizontal demand curve, the elasticity is infinite. Why infinite? Because there's no change in price. There's no change in price. Only quantity is changing. But how do I know that it's infinite? Look at the formula. Formula is percentage change in QD, X, and I know the QD is changing, divided by percentage change in price. Price is not changing. So 0. So 0. So any number divided by 0 is what? Divided by percentage change in price. Price is not changing. So 0. So 0. So any number divided by 0 is what? Infinity. So elasticity is infinite. And finally, which is beyond the jurisdiction of this course, I have seen though this diagram in your textbook. So this is another curve. Now see, this is not a straight line. So I know that slope on each point of this curve, is changing. You have different slope at each point. But elasticity is constant, luckily. So we have this function. So if you calculate elasticity between any 2 points, you will always not, unlike in this case, you will get the same elasticity. I did not say that it is -2 or -1 or -0.5. Whatever number it is constant. And this is basically a Cobb-Douglas function, which is beyond the jurisdiction of this course. What you need to know is only the shapes of these demand curves. This is very important. This, which I'll be using in the later chapters as well. Okay. So let me stop here, and this is the last topic. That is, we'll discuss the application of elasticity of demand, and then we discuss elasticity of supply instead of elasticity of demand, and then we discuss income elasticity of demand, and then we discuss cross price elasticity of demand in the next session. Thank you so much. Take care. Bye-bye.